Answering questions you may or may not have that we have not answered so far. Where were we at?
18, 9, we've not done 8.
18, let's do 18. 18 should not cause that great of difficulty for you.
Good job.
Who asked me 18? Hi. I suppose the best way to do this, Sage, is just cross multiply. Okay, so you just get this times this, 2.7x equals 12 times 18. And as long as you're doing your multiplication right, how hard would that be? 12 times 18 is 216, correct? Did you do that right? No. Yes. So now it's 2.7x equals 216, just divide by 2.7. There's got to be an easy way out there.
Wait, 2.7 knows you.
On the outside. 2.7 times 216, lose the decimal, add a 0. However many times 2.7 goes into 2000, or 27 goes into 2001. Which is probably what, 8? 80?
Yes.
56, 5, 16, 21, yeah, 80 times. If you really wanted to, and people asked this question the other day, listen carefully. Somebody said, if I multiply both of these by 10, do I have to multiply that side by 10? Well, that was me. No, you don't have to. You can always make equal fractions to anything and not change it. In other words, you could multiply it, make this 120 over 27. You don't have to do anything with this because you're just making an equal fraction. Okay? Then you could have said, oh, well, this could be reduced. 3 goes into both of those. 40 over 9. And then 9 times 2 is that, and 40 times 2 is 80. Either one of those would work just grandiosely. Economy amigos. Am I Haynes?
I think you probably 15.
I guess 15 isn't on this page or something. Oh, 15. If you struggle with 15, again, you've got a graph paper, so you just want to graph this line. Okay, there's 2 ways to do this, and you can pick which way you want. Lucas's manual paper. You don't have any questions about this?
Well,
I'm just gonna say. No, I'm just saying. Alright. Number one way you can graph this line, and the way you graph this line is this is the y-intercept. So here at 1, 2, 3, 4, 5, -5, there's a dot. And the slope of the line is the number in front of the x. So the slope is 3 over 1. You have to make it a fraction because you want rise over run. So from here it goes up 1, 2, 3 over 1. You can put a dot. Up 1, 2, 3 over 1, put a dot. You can graph that line and then check to see if any of these points, one of these points should fall on that line. So you check -2, 1. Well, here's -2, 1. That certainly isn't on the line. -1, 2 certainly isn't on the line. 2, 1, oh yeah, there you go. That one looks like it's on the line. 1, 2, no, that's probably not on the line. So this would be 1. The other way, children, of the proverbial corn, the other way you could check this without drawing the graph, everybody look up here, you don't have to look at Nathaniel, he'll make his way to it. You could take each one of these points, you could take each one of those points and put it in this equation and see if it works out. In other words, put -2 in for, put -2 in for x. Okay, what is -2? A -6. -6 minus 5 would have to equal what this y value is. And if you do -6 minus 5, you actually get -11. That doesn't equal that. You could try with -1. Put -1 in for x. 3 times a -1 is a -3. -3, -5 is -8. You need to get a 2 for the y, so that doesn't work. If you put a 2 in there, 3 times 2 is 6. 6 minus 5 is 1, and that's what the y is, so you know that has to be it. because it's the only point that'll work out and get you an equal time. If you don't like to draw the graph, take a look and see where it's at. Congratulations, such that hitherto, here we go. Yeah, oh, so many questions on price and so few answers. Number 9, is that on this one?
Yeah.
Is it?
like.
It's the barn.
Oh, the barn, here we go, yes.
Do you like, I got it wrong, but I think it's because, do you add the base of the triangles?
Yes, triangles get added to it. If you're painting this building, you're gonna have to paint up there in that, what do we call that? The peak, I guess the peak. Well, no, the peak, the ceiling's inside, you're not painting inside, you're painting outside. You gotta paint this whole thing, so you gotta do the rectangle and the triangle. And Liechtenstein,
Can you do number 18?
is that the one I just did? Nathaniel, can I tell you just cross multiply? 2.7 times x gives you 2.7x. 18 times 12 gives you 216, and you just divide by that number.
Oh, wait, no, never mind.
You were asking me to do 18?
No, I got,
Emma Hayes.
How do you do from 14?
Who?
14?
Anybody else on 14?
Yeah.
See, there is more people out there. More are. No, I In order to do 14, you just have to understand what a box and whisker plot does. Okay, when you do a box and whisker plot, you're just grouping, you are just separating the values into 4 equal quadrants. Not equal score-wise, but equal number-wise. In other words, right here, at this middle point here, you have half the scores that fall this way and half the scores that are above that. Okay, so what happens, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Each one of these separates the data into 4 equal parts. Okay, they don't look equal because they're not separating it by score, they're separating by number of data. So if you want to know the tests that show 3/4 of the scores were at or above what, this is the bottom 1/4, this is the top 3/4. So the scores that were more than 3/4 had to be above this 82. The scores that were less than half had to fall below 90. The scores that were more than 25% or 3/4 would have to be above that. Okay, but this said, which tests show that 3/4 of the scores, 1, 2, 3 of the 4s had to be above that part there. That's what a box and whisker plot does. It divides the data into 4 equal quadrants based on the number of data there are. How many kids got this score, that score, whatever score. Nick Shanks.
For future tests, can we use this?
For future tests, yeah. I said that on the list. You should have to watch part 2 to find that out. You should have to quit. What is this? How?
It's a school. So I just write the word school on it, so I wouldn't
Oh, is
guess
that what
it.
it was? Did you write the word school?
No,
Yes.
she
I wrote it down.
school. I never thought it was church.
Yeah,
You
Nathaniel
wrote a
like
cross
church
on it.
Church.
I was like,
Wasn't your typical schoolhouse when they show it on a clip art or something, looks like this? And it's got like a chimney like this or something.
that looks like a house.
Yeah, hey, you have bread.
I guess there is a bell. Then there's a little chimney up here like this. That's a school. Houses don't have the little bell part of it.
They can't be.
Where's the bell?
Or it's little house.
Yes, Jackson, number 2. Number 20, kids.
You should put a school bus
At a building.
That's what I'm thinking.
At a building.
Hi. Jackson, once again for number 20. Okay, you have to look at the fraction bar as a grouping symbol. You have to get the top down to one number and the bottom down to one number, and then you're going to divide the bottom into the top. Okay, so what you have to do with this is a 2-part top part here. You have this negative 12, which doesn't change. But over here you have 5 times 6, which is 30. And there's 2 negatives, which make it positive 30. So if you if you have 30 and you have to take 12 away from that, you end up with 18. And down here you have two negatives, which give you a positive. 2 times 3 is 6. So what is 18 divided by 6? Nothing more than a 3. Can you get that? Do you understand where that?
I wanna be a,
These addition subtraction signs separate the problem into 2 parts. Yes.
I wanna be a negative.
Negative times 2 negatives, multiply together, give you a positive. Sage, nothing after that?
No.
See, if you're really thinking about studying hard, you wouldn't sit next to him twice. Because you know, you lose a little focus next to him twice. I'm just saying, you still lose a little focus over there. Jacksonian,
Number 1.
el número unos.
That's number 2.
Don't worry, I can go back to 1. Did we do 1 already? Yes, we did. Jack already did number 1. Nathaniel asked me that question. You don't have anything written for number 1? Where were you at when you did number 1?
Space and then
Really? Nathaniel, how does number 1 get done?
First, you have to draw 2 pictures.
And what are those pictures of?
You have to draw the line of the total distance.
Which is how far?
It is 120 miles,
And if you're going at 60 mph, how long does it take you to do that?
2 hours.
Takes you 2 hours to get there. Then you turn around and you come back. How far is it back?
120 miles.
How fast are you going?
40 miles.
Well, if you're only going 40 miles an hour, how long does the back trip take you?
3 hours.
3 hours. How do I find my average? Total of distance divided by total hours. How far did Jackson, how far did this person go? Huh? Went 120 there and 120 back,
240.
240 miles. What was her total time? 5 hours. 3 hours there, 2 hours back. And you divide that out, you end up with 48 miles per hour average.
It looks like a scary symbol.
It's like it's
Yeah,
zone
like-
1.
What is this?
A candle or a phone.
It's a school.
Phone. Dynamite.
Telephone.
See, and you can't.
Yeah, Jackson's guitar.
I thought it was a phone.
I thought it was a juice box or something.
It was like 2 squares.
That is a good talk.
Big radios, laptop,
Jackson,
Can you do number 5?
one more. Oh, yeah. Number 5, if and I was doing number 5. Wait, my voice? Oh, I guess I already have it as far as I can. The deal with number 5, I would say, is this, Jackson. Like I said, you know that this is inverse variation, which means the things multiply. If 4 people can do a job in 15 hours, multiply those together, everything has to always add and multiply together to get 60 now, no matter how many people you do. If you have 3 people, what would they have to do to get 60? 20. But you have how many people? You have 5 painters. So 5 painters times what gives you 60? 12, and that's where that comes from. That is inverse variation. As one goes up, the other one goes down proportionately. This went, where did that go? It went down 25%, so this went up 25%. Is that right? No. Sound easy, though. Nobody else? Don't make me come there and ask nothing new. Don't ask me to do number 19 again. What?
I'm guessing you already did this one, but.
Didn't do 15, did I?
Yeah, you did. It's the coordinate ones with the X,
No,
Y,
I can't do that one again. That took way too long. What's that? Whoever's doing that, please stop.
Let's not plant labels.
Let me ask you, Nathan, Nathaniel, did you graph that line? What did you do to try to figure the answer out?
I don't know, but we were.
So you didn't do anything or what?
I graphed
Is
it.
that what?
I graphed it.
Did you get the right line?
No.
Well, let's one more time review that line thing. Nathaniel, if you have this equation and you graph it, how do you graph it? Based on the information given there, how do you graph that line?
Give the X by itself.
Nope.
Oh, the Y.
The -5 here is where it crosses the y-axis. 1, 2, 3, 4, 5. And the slope is 3. But you want it to be in fraction form, so it's 3 over 1. Up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Here is the graph of that line. Which one of these points will fall on that line? How do you know?
Because it's
Well, you want to look at them. -2, 1 is here. -1, 2 is here. 1, 2 is here. And 2, 1, 1, 2, 1 is right there. So it has to be this one. I'm stopping here.
Stop. Just
For part 3.
And then Lucas Spaniel, I hope gets a very good grade on this test.
No,
Is
it's
that
really
recording?
close.
See, I'm using just because I have to write on the notes.
Okay.
Part 3 makes.
Shout out to Nikki Collins. man.
Hi, Mom.
Wait, was that even recording?
Sad part is,